Good evening, all.
Good evening.
Yeah, we were going with the definite integration, right? Definite integration. So everyone solve this question. Yes, make it fast. Yes, time up. Look at this. So this type of questions you can solve by using the properties. F of x function given, g of x function given, he is asking us to integrate this one. So how can we integrate this function? What property I can use here? Minus a to a to b property. So look at it. Let us consider this as let I is equal to minus pi by 4 to pi by 4. So g of f of x, right? G of x is what? Log bc x. X is nothing but f of x, 2 minus x cos x divided by, okay. So this is what we can just get this into dx. Okay. So now using property, called a to b f of x dx. Okay, is equal to a to b. What is the property? F of a plus b minus x dx. Okay. Then now how can I write this? Minus pi by 4 to pi by 4 log of what you are going to get? 2 plus x cos x divided by 2 minus x cos x dx. Let us take this as first equation. Let us take this as second equation. I'm adding first and second. Minus pi by 4 to pi by 4 log of 2 minus x cos x by 2 plus x cos x into log a plus log b, log ab, correct? So basically look at this will be getting cancelled. So log 1 is 0. So answer is, so 2 times of I. So 1 plus 2. So 1 plus 2 is nothing but I plus I 2i minus pi by 4 to pi by 4 log 1 dx, which is 0. This is 0. I is equal to 0. I is equal to 0 or not? I is equal to 0 is nothing but log 1. 0 can be written as log 1. I think options he has given in terms of log. Option 4 is correct. Make it fast. Copy this. Next question. Next question. Everyone solve this question. Quick. Everyone solve this question quickly. Zero to pi by 2 sin cube x divided by sin x plus cos x. Guys, this is a very simple question. Direct property. What is the property we can use here? Look at this here, what he has given. 0 to pi by 2 sin cube x divided by sin x plus cos x dx. Right? So what property I can apply here? So let us take this as first equation. So the property 0 to a f of x dx is equal to 0 to a f of a minus x dx. The property whichever we have used in last question, this property is a special case of that property. Okay. So now what is let us say this as I beta. Okay, this is, let us take this as I, and this is also I. Now after applying property 0 to pi by 2, okay, a minus x. So 90 minus theta, so cos cube theta, cos cube x divided by sin 90 minus theta, so cos x plus sin x, so sin x plus cos x only. After applying this property also again, the denominator will be the same one. Okay, so this is my second equation. Okay, the first plus second, the first plus second, I plus I is what, 2i is equal to, so 0 to pi by 2, 0 to pi by 2, what you are going to get now, sin cube x plus cos cube x whole divided by sin x plus cos x dx. Okay, so now tell me what can we write this as. 0 to pi by 2, this can be written as 2 minus sin 2x. How 2 minus sin 2x? We have sin cube x formula, cos cube x formula. Substitute that, solve this, and tell me the answer now. Make it fast. Make it fast. Very simple question. Excuse me. Yes. Sir, I do not want to use the property here. I just want to use some other technique, and you can use that as well. In the numerator, you can add and subtract sin x beta. Applying the property one method, And another method is what? Another method is you can add and subtract sin x in the numerator. Got it, guys? You can use whatever the technique you want to use, Rababu. Look at it, it's very, very simple. And I can use an algebraic identity also. AQ plus BQ is what? AQ BQ formula is what? A plus B whole cube minus 3 times of AB into A plus B. Okay. Now A plus B whole cube is nothing but A plus B whole cube minus 3AB into A plus B. Sin x plus cos x. Okay. Now, very simple, Rababu. Look at this, everyone. After this, very, very simple, you can make this. 2i is equal to 0 to pi by 2. You can split this. What you are going to get? Sin x plus cos x whole square minus 3 sin x cos x dx. Okay. 2i is equal to 0 to pi by 2. A square plus b square. Sin square x plus cos square x will be 1 plus 2 times of sin x cos x minus 3 times of sin x cos x. Okay. So now look at this here. 2 times of I is equal to 0 to pi by 2. 1 minus sin x cos x dx. Right? So, what can we do here now? Very simple. Very simple. Look at this now. Straight away you integrate this. 2 times of I. 2 times of I. 0 to pi by 2. Integral 1 into dx is what? X from 0 to pi by 2. Minus integral 0 to pi by 2 sin x into cos x dx. So 2 times of I is equal to, so pi by 2 minus 0, right? Minus, you're multiplying and dividing with the 2 above. So 2 sin x cos x is what? So 1 by 2 times of, so integral 0 to pi by 2, 2 sin x cos x is sin 2x into dx. Okay. Now what can we do here? 2 times of I is equal to pi by 2 minus integral sin 2x is what? Very simple. Integral 1 by 2 integral sin 2x is what? Cos 2x by 2, right? So sorry, minus cos 2x, right? So plus, it becomes plus. So I is equal to what now? Pi by 4 plus 1 by 8. 2 to the 4. That 2 will come to the denominator. So cos 2x by 8. So I is equal to LCM is 8, 2 times of pi plus cos 2x. This is my answer. Where what is the options he has given? Oh, pi by something he has given, but our options are not matching. How can we do this? I think we didn't apply the limits. I'm sorry, guys. Look at this. We didn't apply the limit 0 to pi by 2. Yes. We forgot that. Yes. So if you forget that, everything will be collapsed. Okay. So what I do here is 1 by 4 cos 2 times of pi by 2 minus cos 0. Okay. Cos pi is what? I is equal to pi by 4 plus 1 by 4. Okay. Cos pi is 1. So minus 1 0. Minus 1 minus 1. Am I correct? Yes. Pi by 4 minus 1 by 4. So pi minus 1 by 4 is the answer. Pi minus 1 by 4 is the answer. Pi minus 1 by 4 is the answer. Option B is correct. Next question. Any doubts? Children, any doubts here? Oh, acha. This is 2, right? Pi by 2. Cos 90 is 0. So cos 0 is 1. So minus 1 I wrote like that. Are you people able to understand what I wrote here, guys? Here already we have 2. So cos pi by 4, since we have 2, 2. So 2 to the 4. Cos 90 is 0. Cos 0 is 1. So directly I wrote like this. Children, any doubts? Already 1 by 2 we had, 1 by 4 it became. So 2 to the 4, right? Pi by 2 by 2, so pi by 4. Hope you people are getting the point. Pi minus 1 by 4, option D is correct. Option B. Next question we can go for is, solve it patiently, you will get the answer for sure. Next question. Everyone solve this question. Everyone make this question. Make it fast. 1.5 minutes of time. Quick. Guys, this is a kind of lengthy calculation, but easy, and already we have done this type of question. Done, guys. Done. What is the idea? Done, guys.
Look at this very simple problem. So 0 to 1 x into not equals of 1 minus x square plus x to the power of 4 into dx. Right? So let's go with input substitution method. X square as t. Right? So 2x into dx is equal to dt. So x into dx is equal to dt by 2. Right? So this is what you get. Now what this is going to become, limits will be changing. What are the limits? If x is equal to 0, what is t? T value is also going to be 0. Right? 0 to, and what if x is equal to 1? What is t value is going to be? It's going to be 1. Right? So x into dx, this x into dx can be written as 1 by 2 times of dt. So cot inverse of 1 minus t plus t square, correct? Into dt. Any doubts, guys? Very simple, right?
Guys, can you hear my voice clearly? Hello.
Yes, sir, you're audible.
Now, yes. So this is what I can write beta here now. So cot inverse, we will be writing this in terms of tan inverse. So if I write in terms of tan inverse, what happens beta? It will be reciprocal, like 1 by 1 minus t plus t square into dt. Pretty simple. So what can we go with? 1 by 2 in times of tan inverse of. See, whenever you get this type of situation, beta, we already seen many questions. We have to add and subtract something. So let us add and subtract something. So which is what I'm doing here is, let me add and subtract t. So 1 1 plus t minus t divided by 1 plus 1 minus t plus t square into dt, right? Now what I do here is, so here let us write like this, the numerator part, t minus of t minus 1. Can I write like this? So that, look at, if I solve this the numerator part again, I'll get 1. Okay, so 1 by 2 times of tan inverse of, isn't it looking like, guys, look at this, isn't it looking like tan inverse of a minus b formula, a minus b by 1 plus a into b, isn't it? So how it is looking like, I'll show it to you. Look at this, tan inverse of a minus b divided by 1 plus ab. So taking t common, a into b, look at this into this t square minus t. All right, satisfying or not? So now this will be what beta? 1 by 2 times of 0 to 1, 0 to 1. Can I write this as tan of a minus tan b? This is tan inverse of a minus. So we know that, boys and girls, from the inverse trigonometry function, what we learnt, tan inverse of x minus tan inverse of y is equal to this function. Okay, we know this. So let me erase this. Now 1 by 2, 0 to 1. This is looking like tan inverse of a minus b by 1 plus ab. This is how it is looking like. Okay, so tan inverse of x minus, right? So tan inverse of x, what is x? T. So let me write directly tan t, babu. Tan t minus tan t minus 1 dt, right? So what you left with now? Integrating it directly. 1 by 2 times of 0 to 1. Sorry, tan inverse, right? Tan inverse. So 1 by 2 times of, so tan inverse of t minus this one. So guys, how can we solve this now? It is a tricky now. So we will do one thing. We don't know how to solve this. Let us take this as I. Okay, I'm solving I now. I is equal to 0 to 1 tan inverse of t minus 1 dt. Okay. So can we use the property called 0 to a f of x dx is equal to 0 to a f of a minus x property? Isn't it, boys? So what is this going to be now? 0 to 1 tan inverse of, this can be written as a. What is a here? 1 minus x. X is nothing but t minus 1. So plus 1. Hope you are getting my point. Sorry, a is 1. So plus minus t minus 1. This will be getting cancelled. Okay. So this is your I, right? I is equal to what you are going to get now? Minus 0 to 1 tan inverse of t, right? So this is my I, right? Yeah. Now this is minus tan inverse of t. So let us substitute in the star equation. Let us take this as star equation. In a star equation, I'm substituting this I value. So from that 1 by 2 times of 0 to 1 tan inverse of minus, what is this? Minus into minus plus, right? So tan inverse of t to dt. Guys, I value is minus. In terms of minus, we have I value. So here also I have minus in a star equation. So minus into minus plus. So that is how I wrote plus there. Now 1 by 2 times of, so tan inverse of t plus tan inverse of 2 times of tan inverse of t. So that 2 times of tan inverse of t into this 1 by 2. 2 will be getting cancelled. Okay. So let me write directly 0 to 1 tan inverse of t dt you got. Okay, people. Yeah. Now, so how can I solve this? How can I solve this? By using by parts. This can be written as tan inverse of t into 1 into dt. So we know that by parts formula. What was that? Integral uv is equal to u integral of second function minus dy dx of the first function into integral v into dv, right? So this was the thing we had, right? Okay. So by parts formula we'll use this. So integral islet as per the islet, first function is what? Tan inverse of t. Okay. So we are integrating this, right? So tan inverse of t into t minus d by dx of u. What is that? Tan inverse. So 1 plus t square into dt. Sorry, t dt into t, right? Into v t into dt. So from where to where? 0 to 1. Correct? So this is what I got. Now t into tan inverse of t minus t by 1 plus t square 0 to 1. Right? So now t tan inverse of t minus, substituting the limits, 1 by 2 log of 1 plus t square, right? Isn't it log? So 1 by so integral t, so t square by 2. So that is how we got this, from where to where, 0 to 1, right? This as it is, Rababu, this integrating, I've got this. Now substituting the limits. So 1 into tan inverse of t. So tan inverse of 1 minus 1 by 2 times of 2 minus 0, 0 into something 0, so it will be 0 only. So this will be pi by 4 minus 1 by 2 times of log 2 will be the answer. So which option is correct? Pi by 4 minus pi 1 by 2 log 2. Pi by 4 we have pi by 4. Option D is correct. Option D is correct. Next question. Next question. Any doubts, children? Guys, I'm going very slow, detailedly everything, we am writing. See, these integration questions will be like this only. As I told you, you don't have other option. You have to solve this. That's it. Quick.
And now look at this. So very simple only. Let is equal to 0 to pi sin 2x. Okay. So let us take this as first impression. We can apply this property. A to b of x, x is equal to a to b f of a plus b minus x dx. Okay. So now I is equal to what it becomes 0 to 2 pi say a plus b f of in place of x. In place of x, I will be substituting a plus b minus x. So 2 pi minus x. So sine 4 pi minus x. So minus sine 2x. Correct? Cos of 3 of 2 pi minus x. Same one. The same. Okay. This is second one. Else 1 plus 2. So add this sine 2x. Guys, this box representing what here? Guys, this is box representing greatest integer function. What is that? Greatest integer function. So don't think that I'll cancel these two and be writing that. Okay. Now see here, if you as we know that okay, this will be always what? Minus one. Okay, sir, how it is minus one? How it is minus one? Tell me, guys. It is always going to be minus one beta. How minus one? If you want to check, you can check it out. You can take any example and check it out. Look at this. Let me say that. So x value I'm taking somewhere 2.6. Okay, x value I'm taking 2.6. So step of 2.6 is 2. Step of 2.6 is 2 plus step of minus 2.6 is what? Minus 3, right? So we will be always taking. So look at it, 2 minus 3 will be minus 1. So for negative values, we will be taking always left side value in greatest integer function. So if I write 1.5, I'll be taking greatest integer as 1. If I write minus 2.6, I'll be taking left side value as 3, minus 3, right? So that is how I got minus 1 here. Now similarly, here same value I have. So this is, if I consider this as x, this is going to be minus x. So step of plus x, step of minus x is always going to be minus x. Right? Now what is this going to be? 2I is going to be, so integral 0 to pi beta, this is minus 1 dx. So 2I is going to be minus 2 pi minus 0. So so look at this, minus I value is going to be minus 5 is the answer. I value is 5 is the answer. So it is 0. 0 doesn't make a sense. So minus 5 is the answer. Minus 5. So square. Which option is correct? Option B is correct. Okay, people. Are you guys able to relate the things? Pawan, Alisha,
Yes, sir.
very good. What about other passed out 12 students? Shruti is joining now. Hmm. I'm going to end up the session. She is joining now. Shruti ji, you are joining now. Shruti ji, why Shruti?
Sir, I came just now from college.
So everyone saw this. Let's take this question as homework. Take this question as homework. Next. Okay, guys, solve this question. I'll give a hint here. Very simple question. Let's look at this with 0 to pi by 2. You can use the property. Very simple, guys. Modify this function and write this. 0 to pi by 2 cot x divided by cot x capital sin by cos plus 1 by sin x. Right? Sorry. Cot x be cos x by sin x. Now look at this here. So from this, what can I write? 0 to pi by 2. Cot x is what? Cos by sin. Here, let me write that here. So here cos x 1 plus cos x. Yes. So after this, guys, you just add and subtract something and just see whatever the method you get, you just solve this. After this, guys, you will be having simple steps. You will be having simple steps. Make sure that you are doing that properly. Okay, guys. And I have another class right now. Let me join that. Okay, people. So please do solve the remaining questions. So tomorrow probably we will go with definite integration, or we'll go with a new topic. We'll see. As per the situation demands, we will move ahead. Okay, people. So I think like your exam is nearing up. Make sure that don't waste your time. Do solve previous year JEE questions as I upload in a PDF form as worksheets. Kindly do solve it. Not only the students who are going to write JEE exam, but also the students who are in present 12th right now, like Adesha, Pravalika. I request you people to solve the topics whichever we have covered so far. I'm asking you to attend for even these classes. Why? Because it will be helpful when you listen this class, when you listen this particular topic, when we start for your 12th standard classes. Okay, these topics are really going to helpful. These classes will be helpful to you. Okay, so I'm sure you might not be understanding 100%, but I can ensure you that definitely these classes, these lectures will make you somewhat comfortable when you listen your regular classes. When I start your integration lesson from the scratch, you will be definitely feel comfortable while that time. Okay, thank you, children. Goodbye.